Hi, good morning. I'd like to talk about the assignment 5 before we finish up the chapter 5 on that systematic sampling. Okay. In question 1, let's look at the 1 in 150 systematic sample of a population of 4,500 students on the list, and we obtain one sample. Okay, so how does it work? If I want to put it in a way to show you the true picture of how we obtain this 30 students from the population of 4,500, that means in the original directory, we would have 4,500 students, but we have a systematic sample that is chosen in a way that 30 students were collected from the population, right? So we are looking at 1 in 150 systematic sampling scheme. So let's say if from the list we would have a random start of the first student, then the second student to be chosen for the sample would be the 151st student. And then the third student would be the 301st student, etc., etc. Because every student chosen from the list would be 150 apart. Okay, so I'm going to put it into an Excel spreadsheet so that you can see how it works in the population. Okay, in the population, we would have 45,000 students, but let's say I am going to collect one systematic sample, which is 1 in 150 systematic sample. So the first student from the populations, as the random start is the first, would be that guy. Okay, and then the second student in the sample would be the 151st students from the list of the population, etc. Okay, so I can, at the end of the day, I would be chosen 30 students. Each of them would be 150 apart from each other, and this is chosen systematically. So this is how I choose one systematic sample. With one systematic sample, I can calculate the mean, but I cannot unbiasedly calculate the variance because I only have one mean from the population. If that's the case, we can't estimate the variance of my sample mean unless in the lecture notes we said that unless we try to use the simple random sampling scheme, assuming that the population itself is randomly distributed, then I would say I can still, by the statistical theory, I can still choose different y-bar and then we can estimate the variance. True. So we can use the formula, just like the simple random sampling, to calculate or to estimate the variance. But most of the time, the variance that we calculated will be overestimating the true variance under systematic sampling, if there's any ordered trend within the population. So we say that our first method is to use SRS. Secondly, we can try to rearrange the systematic sample into the repeated systematic samples. So let's say if this question 1 in the assignment C is that if we repeat a systematic sampling 3 times, list out all the possible 1 in 450 repeated systematic samples. So this is how I do that. So in one systematic sample, actually I can divide it into 3 repeated systematic samples if each of the elements within the sample would be 450 apart. So what I'll do is to divide the systematic sample into 1, 2, 3, 1, 2, 3, because I repeated 3 times, 1, 2, 3, etc. Okay, so at the end of the day, I would have sample 1 having those values, and I would have 10 samples collected for sample 1, another 10 from sample 2, another 10 for sample 3. So at the end of the day, I am still having 30 samples from the population, same as the one systematic sample. But I just divide it into 3 repeated systematic samples, and each of them would be 450 apart. So we can see that the first item would, again, the first from the population, and then the second item in sample 1 would be 450 first, and then 900 first, etc. In sample 2, I would have the random start 150 first, and then the 600 first, etc. So in this case, I would have 3 repeated systematic samples, and I have 3 Y bars. I can calculate the means of them, which is the means of means. And I'm saying this is the Y bar, but essentially would be the same as how we collected from the one systematic sample. They are the same. And with the 3 Y bars, now I would have a distribution of the means, and I can actually calculate or estimate the variance of Y bar using repeated systematic samples. Okay, so this is what I'm asking, how to list out all of the possible repeated systematic samples. D, use successive differences method to produce a better estimator of variance. So the other methods we suggest to estimate the variance is using the successive difference. Successive difference is to look at the difference between the Y data that we obtained. So there are 2 ways of doing that. One is called the collapse difference. Secondly is the successive difference. Okay, using the collapse difference, we can use formula 5.10, which we need to look at the variance of the differences and divide by 2n multiplied to the final population correction factor. It is indeed the same as how we estimate the variance of Y bar. If we use successive difference, just a matter of different way of calculating the variance of the difference. Okay, so we're looking at the successive difference. So Y1 the difference of the 2 values, but successively. By the way, I mean successive. That means Y2 minus Y1, then Y3 minus Y2, etc. Okay, so at the end of the day, I would be able to obtain n minus 1 numbers of the differences, and taking square of these differences and divided by n minus 1, and that 766 is the SD square for the formula 5.13. Substitute into 5.12 divided by 2 times 30 multiplied to the final population correction factor, we can find the estimated variance. Okay, so if we obtain this estimated variance of Y bar from the differences method, if we look at the value as compared to the estimated variance from the SRS method, if there's a substantial reduction of the variance estimate, we can say that would be some trend within the populations, either a cyclical trend or an increasing or decreasing trend of the original data. Okay, if the variance we see is not substantially different, then we could not say they have a very significant differences. Okay, like the example in the lecture 5.5, we estimate the variance using SRS method 0.196 as compared to using the differences method. They're quite similar, so we can say that they are somewhere no trend at all of the original data set. Whereas in example 5.6, we can see using the SRS formula, as compared to using the difference method. That's a very big reduction of the estimated variance. So we doubt that using the SLS method would overestimate the true variance of the population. Okay. All right. So that's it for the pulling around. So this is assignment 5, question 1. The rest of the question would be similar. Only on question 5, I'd like you to discuss about what's the best choice of the sampling scheme if we have some of the ordered population, or if the population is randomly distributed, etc. Okay, and one interesting observation under the systematic sampling is that we could have the population size that is given for the 500 students, and then we decide how we choose the sample systematically. But some of the times we may not be able to have the population data. Let's say if I choose the shoppers who came out from a supermarket on a daily basis. So I choose every 10th customer who walked out from the supermarket. Then I'm choosing the sample systematically, because 1 in 10th systematic sample that I choose, but I may not be able to obtain the total number of customers who would walk out from the supermarket on a daily basis. So if that's the case, we can assume n equals infinity, but we choose a systematic sample until we reach our sample size. Let's say we decided n, the little n, my sample size is 30, until we collect the 30 customers and we are done. But we, at the end of the day, we are still choosing our sample in a systematic way. Okay, so the due date for assignment 5 is next Monday. So good luck on systematic sampling.